The random variable x is normally distributed with a mean of 15 and standard deviation of 2.7. Number 1, sketch a graph of the PDF associated with x. X is normally distributed, and it has a mean and a standard deviation, but the fact that it's normally distributed means that the graph of the PDF is a bell curve. So it looks something like this. And the center, or the middle of the graph, it's supposed to be symmetric about that middle. That is the mean of 15, and the standard deviation is 2.7. So where do we put the standard deviation? You put the standard deviation approximately at the place where the graph reaches 60% of its maximum height. Here's the maximum height. Here's half the height, so a little higher than that. So right about here. Right about here, about 60% of the height, we have one standard deviation. Below, the standard deviation is 2.7, so 15 minus 2.7, and then on the other side, one standard deviation above, 17.7, and we're interested in 11 later on. So if we go 2 standard deviations, we subtract another 2.7. This is 9.6. And then on the other side, another 2.7 above 17.7 is 20.4. So that's our sketch. And now we'll use a sketch to approximate the probability that x is greater than 11. So I'll piggyback on the sketch we just made rather than making a new one. 11 is right about the middle of these two guys. So here's where 11 would be on the scale, and we want the probability that x is greater than that. That means we need the area to the right of that line. The area to the right. Well, that's most of the area under the curve. There's only this little tiny bit in the tail left over. So I'm going to say that there's probably even less than 10% in here. So I'm going to say there's only about less than 10. So 9%, somewhere in that area. And that means this big shaded area is about 90%. And that's really about as good as we can get from a sketch. Number 3, use a sketch to approximate the 23rd percentile. Okay, so if we again, I'm gonna draw a new graph for this one. If we again sketch the normal curve, 15 in the middle, and then again we cut the maximum height in half. We're out about here, so a little bit to the right of that. That's going to be one standard deviation away, or 12.3, and then 2 standard deviations away is going to be over here 9.6. And I won't bother with the right side because we're looking for the 23rd percentile. That means a line for which, or a place, an x value for which 23% of the graph is to the left. We need 23% of the area to be to the left. Well, because this tail is so small, there's not much area in here until you get out to, around here where it starts getting higher. Then you get a little bit more area. So if we want to capture a quarter of the graph, maybe about that much. That's about 25% of the area right there. So 0.23 in area. And now we have to look down here on the x-axis. Well, where is that line located? It's located between 12.3 and 15, closer to 12.3 than 15. So we're going to say that the 23rd percentile is approximately 13, and that's about as good as we can hope to get, again, because we have a sketch. We're just eyeballing this thing, and 13 is a good answer.